Welcome to Mrs. Bays' 6th grade math video lesson. This is the second video in the series on factors and multiples. In this lesson, we're going to focus on the least common multiple. Please do not use a calculator, but you may use your multiplication chart and hundreds chart. Let's begin by looking at the vocabulary for this lesson. Number 1, multiples. Well, multiples are, maybe examples would be easier. Let's say we want the multiples of 2. So the smallest multiple of 2 would be 2, then 4, 6, 8, 10, etc. And we're going to use the 3 dots to say that we could keep going. Factors, those are numbers we multiply together to get a product. Prime numbers are numbers that have only 2 factors. 1 is always one of those factors, and then whatever the number is, that's the second factor. Now let's focus on least common multiple. Well, least means the smallest. Common means that the factors will be in both. So I just added a note that common means that the factors or numbers, and in this case the multiples, will be found in both. And then the multiple, that's like the example I gave up here. It's like 2, 4, 6, 8, 10, 12, 14, 16, and so on. Let's look at some examples. So again, in this lesson, I'm going to show you how to find the least common multiple using 3 different methods. And we're going to start with the tree diagram method. So let's start with the first example, 8 and 9. And the tree method means we're going to start with 2 branches. 8 is an even number, which means the smallest prime number is 2. So 2 times what is 8? Well, that's 4. And 2 is a prime number, so we're going to circle it. 4 is composite, it's not prime, so that means we need to give our 2 branches. And then think about, well, what would be the smallest prime number for an even number? And that's 2. So 2 times what is 4? Well, that's 2. So we know that these are primes. And well, let's just take a second and just review. Here's our chart that we've been looking at for last week and this week. And notice that 1 is a factor in all numbers, so we don't call it prime or composite, but we're looking for 2, 3, 5, and 7. These are the 4 that are the most common. And when I am asking for a prime number, we use 2 for even numbers, 3 for odd numbers, most odd numbers. And if you have an even and odd, we try 3. Okay, so let's go back. So now let's go to 9, and let's start with our 2 branches. And since 9 is odd, that means we're going to use a 3 because that's the smallest prime number for odd numbers. So 3 times what is 9? Well, that's a 3. And we just looked at the hundreds chart, so we know that the 3s are prime. Now let's find that least common multiple. So to find the least common multiple, I'll put a put my line here for my answer. We go to the first number. And since multiples are numbers that are bigger than the numbers given, we're looking at the first tree, and we need all of the prime factors that make up the first number. So that means I need this 2, and the second 2, and the third 2, and now I'm ready to go to the second number in this pair. And now I think about 9, and it has 2 factors, 3 and 3. So I think about the first 3, and I look to the first tree. Did I use a 3? Well, no. So that means I need to keep that 3 and use it in my answer, in my product that I'm about to get. And I notice that I have a second 3, and I look over here and I say, well, no, I didn't use a second 3, so that means I need that 3. And now we need to multiply. 2 times 2 is 4, and 4 times 2 is 8. And look here, 3 times 3 is 9, so 8 times 9 is 72. So the least common multiple of 8 and 9 is 72. Okay, let's look at the second example. And again, we're going to use the tree method or tree diagram. We're starting with 3. So what 2 factors do we multiply together to get 3? Well, 3 is an odd number. That means we want to start with the smallest odd prime, and that would be a 3. So 3 times what is 3? Well, that's 1. 3 is a prime number, so I'm going to circle it. 1's not considered to be a prime or composite, so I'm going to leave that alone. Now let's go to 12. 12 is even. So the smallest prime number is 2 for even numbers. So 2 times what is 12? Well, that's 6. 2's prime, so I'm going to circle it. 6 is composite. That means we need to keep working. So what's the smallest prime number for an even number? Because 6 is even, well, that's a 2. And 2 times 3 is 6. Well, we now know that 2 is prime, and so is 3. So now we're ready to look for our least common multiple. So I look at the first tree, and I know that I need to use this 3. And remember, we're not going to use the 1 because 1's a factor in everything. Let's go to the second, and I look, I see a 2. So is there a 2 over in this first diagram? No, so I need that 2. And here's a second 2, so I look over here, do I have a second 2? Oh, no, so I need that 2. And then I look and I see a 3, but I had a 3 in the first tree, so I do not need that one. So I'm going to mark that one out. And now we're going to multiply the prime factors we have left. 3 times 2 is 6, and 6 times 2 is 12. So the least common multiple of 3 and 12 is 12. All right, let's look at the last example. Let's start with our tree. 24 is an even number, which means the smallest prime number for an even number is 2. 2 times what is 24? Well, that's 12. Let's keep this 2 because it's prime. 12 is even. That means we need to break it down and write and show our branches. 12 is even, so we need to start with 2. 2 times what is 12? Well, that's 6. Let's keep that 2. 6 is still even. It's not prime, so that means we need to show the branches for that. 6 is even, so we're going to start with the lowest prime number, which is 2. 2 times what is 6? That's 3. So we know 2 is prime, and so is 3 prime. And we're done with 24's tree. Let's go to 27. Start with our 2 branches. 27 is an odd number. So the smallest prime number for an odd number is 3. Well, 3 times what is 27? Well, that's 9. 3 is a prime number, so we'll circle it to keep it. but 9 is not prime, it's composite, so it means we need to break it down or show the branches. 9 is odd, so again we need that lowest odd prime number, which is 3. 3 times what is 9? Well, that's 3. And now we know that 3 is prime, so we're going to keep both of those. Now let's look at our least common multiple. So we go to the first tree, and we're going to need all of those numbers, all of these prime factors. So I'm going to write down 2, because I'm keeping it. 2, we're keeping it. Times 2, we need to keep it. Times 3, we're going to keep it. But now I go to the second tree, and the first factor is a 3. Well, when I look at this tree, I already have a 3. So I don't need this one. But then I go to this 3. It's a second 3. So do I have 2 3s in the first tree? Well, the answer is no. So I do need this one. So I'll circle it. And now I have a third 3 in this tree. So I need to go over here and see if I have 3 3s in this tree. Well, no, I only have 1, which means I'll have to write it again. And now we are ready to multiply. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So I'm going to stop here and I'm going to put a 24 here just to help me keep track. Now I need to know, well, what's 24 times 3? So I'm just going to make me a little note to help me out here. 4 times 3 is 12. 3 times 2 is 6 plus 1 is 7. So that means with this 3, I have a 72. Now I need to times by this 3, so again, I'm going to make me a little note. 2 times 3 is 6, and 3 times 7 is 21. So the least common multiple between 24 and 27 is 216. Let me show you another method. That was the tree diagram method. Let me show you a second method, and this is the cake method. So for the cake method, this is, remember, we're just looking at thinking about a layered cake. So in this method, our bottom layer of cake, we have our 2 numbers that we're looking at, 8 and 9, and we are looking for the smallest prime number that will go into 8 and 9. Well, 8 is even, 9 is odd. So when you have that, you should be thinking, well, I need to try to divide both by 3. But the problem is 3 doesn't divide 8 evenly. Now, 3 goes into 9 evenly, but not 8. So do we have a common prime number between 8 and 9? The answer is no, we don't. So I'm going to make a note here that there is no common prime factor. So what do we do in this case? We multiply the 2 numbers together. 8 times 9 is 72. So the LCM, the least common multiple, that's 72. Okay, let's look at the next example. We have 3 and 12, and notice I already have 3 and 12 in this layer of cake. 3 is odd, 12 is even. So when you have an odd and an even number, you're supposed to try to divide both by 3. Well, can 3 divide 3 evenly, and can 3 divide 12 evenly? Answer is yes, so we're going to put 3 out in front. 3 divided by 3 is 1, and 12 divided by 3 is 4. And we cannot make this another layer of cake. We cannot keep dividing because we do not have a common factor between 1 and 4 other than 1. And that's not going to really help us any. So now if I want to find the least common multiple using this, if you will remember, from greatest common factor, we're going to use the icing on the side, which is the 3. But we're also going to use what we're going to call here is the top of the cake. So that's 1 and 4. And we just multiply those factors together. 3 times 1 is 3, and 3 times 4 is 12. So 12 is the least common multiple between 3 and 12. All right, let's go to our last example using the cake method, and that's 24 and 27. We have an even and an odd, which means we need to try to divide both by 3, and that does work, so we're going to put a 3 here. 24 divided by 3 is 8, and 27 divided by 3 is 9. Now we look at 8 and 9, we're trying to figure out, well, do we have another common prime number that will divide both of these? And the answer is no. So that's as far as we can go with this cake. So now let's look at the least common multiple. We use the icing on the side, and that's a 3. And then we go to the top of the cake. This is the topper, and we need the 8, so we're going to times by 8, and the 9. And we're going to multiply those factors together. 3 times 8 is 24. And now 24 times 9. Well, 9 times 4 is 36. 9 times 2 is 18, plus 3 is 21. So the least common multiple is 216. So that's the second method you may choose to practice finding least common multiple. And let me show you one more method for finding least common multiple. And this is the list method. We're going to list the multiples of these. So notice that I have 8 and 9 again, and I put a little line underneath of it, so I know that those are the numbers that we're going to find the multiples for. Let's start with 8. So multiples, I start with, and this time I'm going to go down the page vertically. So I'm going to start with 8. The first multiple of 8 is 8. The second multiple of 8 is 16. The third multiple of 8 is 24. So see what I'm doing? 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. 4 times 8 is 32. Next is 40, 48, 56, 64, 72, and 80. So right now I've just listed the first 10 multiples of 8. So now let's go to 9. The first multiple of 9 is 9. Second multiple of 9 is 18. So this is 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36. So now I'm going to just continue with the multiples. That would be 45, 54, 63, 72, 81, and then 90. So this is the first 10 multiples of 9. Now to find the least common multiple, least means the smallest. I want to find the smallest number that is in both columns. So when I look down this list, I'm looking for the same number in both columns, and here I am. I'm at 72. So the least common multiple between 8 and 9 is 72. Okay, let's go to the second example. This is 3 and 12. And again, I want to start with 3. The first multiple of 3 is 3. The second multiple of 3 is 6. So that's 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 12, 15, 18, 21, 24. I think I'll stop there for right now. Let's go to 12. The first multiple of 12 is 12. Second multiple of 12 is 24. Next is 36. And then 48, 60. Let's stop there for a second because 60 is much bigger than 24, so I could continue this list, but let's look at these and see if we have a common multiple that's in both columns. So here's 3 and 6 and 9, and well, here's a 12 and here's a 12. But if I keep looking, I have 24 and here's a 24. So could we have two answers that the least common multiple of 3 and 12 is 12 and 24? Well, the answer there is no, because of the definition of least common multiple. We want the smallest, the least common, meaning in both columns, and we want a multiple. So what's the smallest? What's smaller between 12 and 24? Answer is 12. So the least common multiple of 3 and 12 is 12. So notice in numbers 1 and 2, I showed my multiples going down. And in this case, I went down the first 10 multiples. And here I just went down several. And then I found out that 60 is quite a bit higher than 24. And that's why I kind of stopped there. But now on number 3, I want to go across. Number 3, I'm going to go across, just so you can see that you can either write your multiples going down the page vertically or horizontally across the page. So let's start with 24. The smallest multiple of 24 is 24. Then the next one is 48, because 24 times 2 is 48. 24 times 3 is 72. And I'm going to keep writing the multiples, which is just adding 24 each time or multiplying by the number that we're on. So I'm on 1, 2, 3, 4, 5. 24 times 5 is 120. And let me stop here for just a second. We're getting into some pretty big numbers. So now let me go to 27. So I'm going to start with 27 being the smallest multiple. 27 times 2 is 54. 27 times 3 is 81. 27 times 4 is 108. 1, 2, 3, 4, 5. 27 times 5 is 135. And notice I don't have anything common yet. And we're already in some pretty big numbers. So when you have larger numbers that you're supposed to find the multiples for, you may not want to use this list method. You may want to decide to use either the cake method or the tree diagram method. But I am going to continue here to show you that it is possible to find the multiples, but just understand that these numbers are going to get much bigger as we go. So let me go back to 24. We're on 1, 2, 3, 4, 5, 6. We need the sixth multiple of 24. So 24 times 6 is 144. Next would be 168. Next is 192. Now we're hitting 200. It would be 216. All right, let's look at 27. So 1, 2, 3, 4, 5. We need the sixth multiple. 27 times 6 is 162. Next would be 189. And then 216. So now if you look at this, I'm going to stop there. Now if you look at these two rows and see which number is the same in each row, notice it's 216. So the least common multiple is 216 between 24 and 27. But notice these numbers do get rather large. So again, you may choose to look at the cake method or the tree diagram instead of the list method, especially when your numbers get much bigger here. Okay, so I showed you three methods: tree diagram, cake, and list. You need to decide which method is best for you so that you can practice. And so here's the practice I'd like for you to do. Again, this is the second video for factors and multiples. We're focusing on least common multiple. And the practice I want you to do is IXL, 6th grade, E.10, and you should see the words least common multiple. Be sure you go to 80% to get full credit, and 100% you'll get a bonus point. Good luck!